1.3. Alright, already recorded. Thank you. Evaluating limits analytically. So today we're not going to be just guessing and checking. We're not going to be looking at a table or looking at a graph. We're going to be actually evaluating limits because, again, 2/3 of the AP exam is without a calculator. So there are going to be limits on the non-calculator section that you're going to have to calculate. Now, some limits are extremely easy. For example, the limit as x approaches 2 of x squared. So what do you think it would be? 4. How did you figure that out? You plug 2 in for x, and you get 4, right? That is a direct substitution. And you should always try a direct substitution very first on every problem, on every limit problem. Now, this limit, there was no issue. Where if we had the limit as x approaches 2 of 1 over x squared, you can't do a direct substitution formula. Sorry. X squared minus 4. Okay. You can't do a direct substitution here, can you? Because you get division by 0. This is where you would do something else. Okay? As a matter of fact, on that one, you have to use a table or calculator. Well, you would have to graph it or use a table. One of the two. So it's ugly. Okay? This one gets really ugly. But what I'm saying is, sometimes you can do a direct substitution. Sometimes you cannot do a direct substitution. But you always try because it's the easiest way. Now, let's look at this one. What if we have the limit as x approaches 1 of x squared plus x plus 2 over x plus 1? Can you do a direct substitution here? Do we get division by 0? No, let's just do a direct substitution. That's 1 plus 1 plus 2, that's 4 over 2 is 2. Done. Right, see how easy that is? Alright. Now, let's try this one. The limit as x approaches 1 of x cubed minus 1 over x minus 1. Excuse me? Oh no, but when I say it, it doesn't matter what I write. Okay. So we have the limit as x approaches 1 of x cubed minus 1 over x minus 1. Now, can we do a direct substitution here? No, we get division by 0, right? Okay, so we're going to have, now, we don't have a calculator. So, yeah, don't pick up the calculator, not in this section. Okay, we don't have a calculator right now. So, yeah, you have to do your homework without a calculator today. So, how are we going to find this limit? Well, we're going to algebraically simplify this problem. We're going to factor the numerator. This factors into x minus 1 times x squared plus x plus 1 over x minus 1. That is a difference of cubes. You have a formula for that, right? Now, look what happens to the problem. What happens? We cancel the x minus 1. Now, the x minus 1 was the problem, correct? The problem with this problem is that we got division by 0 because of 1 minus 1 is 0. Now that that's gone, we have the limit as x approaches 1 of x squared plus x plus 1, which is 3. Right? Once you get rid of the problem piece, now do a direct substitution. You're always looking to do a substitution. Right, so let's find it out. Here's another very similar problem. The limit as x approaches -3 of x squared plus x minus 6 over x plus 3. Can we do it a substitution? No. So what do we need to do? Factor and cancel. Yes. So this factors into x and x plus 3 minus 2. I was hoping to get an x plus 3 on top, but you know what? Sometimes you don't. Sometimes it just doesn't happen, and then you have to do something else, which there's another formula we can use later on called L'Hopital's rule. We'll get into that, okay? Not right now. Yeah. Yeah. All of these should work out pretty nicely. So the x plus 3's cancel. Now we have the limit as x approaches -3 of x minus 2, and that's equal to -5. Now, do you remember what this number means? This is this is the y value that's supposed to be in this function at x equals -3. That's actually a point. At -3, -5, there's a hole in the graph there. That's what we just found. Because at x plus 3, that's a removable discontinuity. Remember when it cancels off, it's a hole, right? In rational functions, not with all functions, but with rational functions, that's a hole. So there's a hole at -3, -5 in that graph. Okay, so you've got to keep in mind what we're finding. All right, so let's try another one. All right, so here's a good one. The limit as x approaches 0 of the square root of x plus 1 minus 1 over x. So can we substitute in? Yeah, we end up with 0 over 0. Because that's 1, the square root of 1 minus 1 is 0, and over 0, that's 0 over 0, which is indeterminate. So we got to do something. Now, can we factor this? No. Okay, this is not a factorable problem. But this type of problem, you will find we can take care of it by using a conjugate. Does everybody remember what a conjugate is? If it's a plus b, you have a minus b. You have a minus b, a plus b. Okay, so what we're going to do is we're going to multiply both the numerator and denominator of this fraction by the square root of x plus 1 plus 1. Something magical happens. Now, in the numerator, when you multiply conjugates, a minus b times a plus b, what does this turn into? A squared minus b squared. Because the outside and the inside terms are expressed. So we have a squared minus b squared. So what's a in this problem? A squared would be x plus 1 minus, what is b squared? 1 over x times the square root of x plus 1 plus 1. Now, look at that numerator. Does it simplify? Yes. Yeah, the ones cancel, right? So we have x over x times the square root of x plus 1 plus 1. Now, does that fraction simplify? Yes, the x's cancel. What are we left with on top? Just 1. 1 over the square root of x plus 1 plus 1. Guess what just happened? We got rid of our division by 0 here. It's now gone. Now we can do the limit as x approaches, what was that, -1? Oh, 0, sorry. The limit as x approaches 0. Now we can substitute it in because we have 1 over, that's going to be the square root of 1 plus 1 is 2. The answer is 1. There's one more. Okay, we got to do a few things with some special trig limits. Okay, so there are a couple of limits that you will need to memorize. I did not say that lightly. So they will be on the AP exam. The limit as x approaches 0 of sine of x divided by x. Now, there's no factoring, there's no algebraic anything that we can do to that problem. So we're actually going to look at that problem using a calculator. We're going to look at this problem using a calculator. So we end up with alpha y equals 1 sine of x divided by x. And very soon 7. Actually a very nice looking function, very smooth, but there's a problem at 0. Okay, you can't see it, but it's there. If you do, let's do a table set, start at 0. Let's go through, that's fine, 0.001. Table. We get an error at 0. But what's the limit as x approaches 0? 1. Okay. That equals 1. There we go. Alright, you need to memorize this limit. Okay. No. We're not, well, take that back. Yes, there is a way we can do that with a calculator, but not now. It's several chapters from now before we can do that. We can do that using calculus, okay? But this is a limit that you need to memorize just because it's fast and easy and it shows up several times on the AP exam. And if you know it, what you have to do is answer the question. You don't have to do the calculus if you know the limit. There's only 2 trig limits you need to memorize. That's one of them. The other one is this one. The limit as x approaches 0 of 1 minus cosine x divided by x. This one is equal to 0. Okay? Alright, now let's do a problem that uses one of these. Let's say we have the limit as x approaches 0 of sine of 4x divided by x. What do you think it's going to be? How do you know it? Your guess? A very educated guess. Well, you actually would have guessed right. But if you don't know, you got to know how it's done. But how is that? How is that? How does that happen? Well, what we're going to do with this problem is I'm going to multiply this problem by 4 over 4. Okay? Now, I'm not going to do anything with this top 4. I'm going to leave this as the limit as x approaches 0 of sine of 4x divided by now 4x times 4. When you're going to use that limit I told you about, sine of x over x equals 1, this part and this part have to be exactly the same. Okay? They have to be exactly the same for it to equal 1. So this is 1. See how easy that was? Does that make sense? Okay. So if you ever see a sine over a variable x, you have to make sure that the argument of sine and the denominator are exactly the same before you say it's equal to 1. Okay. All right. I'm done. Homework. Yeah. Forgot which one it was. Look it up. All right, so 1.3.
Multiples of 3.
Huh?
Multiples of 3.
Oh, yeah. Multiples of. Did it scare anybody?
Yeah.
Good. Good.
Just like, are you gonna be like, there's so many